Hi everyone, today we're going to be talking about how to solve proportions, and proportions is just a fancy word for a fraction. We use proportions in a lot of different things, including percents and solving similar triangles and looking at the way that things can compare to each other. And in this case, we're going to go through the proportions, but then use it to solve for similar shapes in the next couple of self-checks. So let's just get started. The first example is 3 over 7 equals 6 over x. Now, we know that it's a proportion because there's two fractions, and when we're solving proportions, usually we have two fractions that are set equal to each other. So there's a couple of different ways that we can do this, but I'm going to show you what I think is the easiest way. So, when we have two fractions that are set equal to each other like this, what I like to do is something called cross multiply. So when we cross multiply, what we're going to do is multiply the top of the first fraction to the bottom of the second fraction, like that. So like 3 times x would be 3x, and then we're going to multiply the bottom of the first fraction times the top of the second fraction, so 7 and 6, so 7 times 6. I'm just going to write it as 7 times 6 so that we remember what it is. So then the good news about this is that when we do this cross multiplication thing, the fractions actually cancel each other out. And so instead of having two fractions, we just have two chunks that are equal to each other. So once again, when we cross multiply, the fractions go away, which is awesome because sometimes it's hard to do math with fractions. So now we have this equation and we have one variable, this x, and so we can actually solve this for x now. And the way that we're going to do that is we're going to say 3x is equal to, we know that 7 times 6 is 42. And then we want to get x by itself, which means that we're going to divide each side by 3. The 3's cancel out on the left side and we're just left with x. And then 42 divided by 3, we can plug that into a calculator and it should be 14. So what that tells me is that x is equal to 14. Sweet. Okay, now let's look at another example. The next example is r plus 10 over 6 is equal to 8 over 2. And once again, we're going to use that cross multiplying. And so I'm going to do it with the different colors again. So we're going to start with the top of the first fraction times the bottom of the second fraction. Now this time, because the top of the first fraction is something with a plus sign, the way that we write this out, we can't just say 2 times r plus 10. We would write 2 and then r plus 10 in parentheses. The reason why we put r plus 10 in parentheses is because when we actually go to multiply it, we need to make sure that 2 that's on the outside multiplies both the r and the 10. Then we're going to do the bottom of the first fraction times the top of the second fraction, which is 6 times 8. I'm just going to write it as 6 times 8 so we remember where it came from. And then, like we said, when we cross multiply, the fractions disappear, so I can just set these two things equal to each other. And now we can simplify and solve. So the first thing, we're going to simplify the left side by distributing the 2 inside the set of parentheses. So 2 times r gives me 2r, and then 2 times 10 gives me 20, so I can say plus 20. And then on the right side, we have 6 times 8, which is 48. Okay, now, once again, we're just going to solve an equation like normal. We want to solve this for r, which means that we need to move the 2 and the 20. The first thing we're going to do is move the 20, and the way we move it is by subtracting it from each side because it's adding right now, so we do the opposite to get rid of it by subtracting. The 20's cancel out on the left side, and we're left with just 2r. Then on the right side, we have 48 minus 20, which gives me 28. Then we still want to get r by itself, which means we need to move the 2. Right now, the 2 is multiplying the r, so to get rid of it, we're going to divide each side by 2. The 2's cancel out on the left side, we're just left with r, and then 28 divided by 2 gives me 14. And r is equal to 14. That is my answer. Okay, so let's do another example. All of these are really similar. They just get slightly harder every time, because there's a few more variables or extra chunks. So 7 over x is equal to 5 over x plus 1. Once again, we're going to do the cross multiplying. So the top of the first fraction to the bottom of the second fraction would give me 7 times x plus 1. Remember, we have to put anything with like a plus or a minus in there in parentheses. That way the 7 or the thing that you're multiplying by can get to all of it by distributing. Then on the right side, we'd have the bottom of the first fraction times the top of the second fraction, which would give me x times 5. We can write it as 5x. And because we cross multiplied, the fractions cancel out. And so now we're just left with 7 times x plus 1 equals 5x. We're going to simplify and solve. To simplify, we start by distributing the 7 inside the parentheses. So we'd get 7 times x, which is 7x. Then 7 times 1, which gives me 7. And then we have that equal to 5x. Now, in this case, we have an x on the left side and an x on the right side. The first thing that we have to do, no matter what, is to get the x's on the same side. And it doesn't really matter which side it goes on. I usually like to move the x's so that there's only one x, or the x's are on the opposite side of the thing that doesn't have an x. And so for that case, I'm going to subtract 7x from each side, because if I subtract 7x, then I have the x's on the right side and then the thing without the x on the left side. It makes for a few less steps. So the 7x's cancel out on the left side, which means I'm just left with 7 right here. And then we have 5x minus 7x on the right side, and 5x minus 7x gives me negative 2x. All right, now we have the x's on one side, the things without the x's on the other, so we can just solve like normal. To solve, we need to get rid of that negative 2 next to the x. It's multiplying, so we've got to divide. We're going to divide each side by negative 2. The negative 2's cancel out on the right side. We're just left with x, and then 7 divided by negative 2 gives me negative 3.5. And so x is equal to negative 3.5. This looks a little bit different than what we're used to. We're used to seeing the x on the left side and then the number on the right side, but it says the same thing. I can write x is equal to negative 3.5 and it doesn't change. Those are the same thing. Okay, last example, which is k minus 7 over k minus 5 equals 9 over 4. Once again, cross multiply. So top first fraction, bottom second fraction would give me 4, and then in parentheses k minus 7. And then on the right side of the equation, we'll have 9 times k minus 5. The k minus 5 is in parentheses. Okay, and then we're going to set them equal to each other because the fractions did cancel out. And now we're going to simplify and solve by distributing. So we're going to start with the left side. 4 times k gives me 4k, and then 4 times negative 7 should give me negative 28. Then we're going to distribute on the right side as well. So 9 times k gives me 9k, and then 9 times negative 5 gives me negative 45. Okay, so now we want to get the k's on the same side and the stuff without the k's on the other side, and it doesn't matter which side the k's end up on. And in this case, there's no like faster version or less steps version. So what we're going to do, or what I'll do, is I will subtract 9k from each side. And when I do that, the 9k disappears from the right side, which means I'm just left with negative 45 over here. And then we have 4k minus 9k, which gives me negative 5k minus 28. All right, now it kind of looks a little bit more like a normal equation that we're used to. So we want to get the k by itself, which means we need to move the negative 5 and the negative 28. I'm going to start by moving the negative 28, and the way I'm going to do that is by adding 28 to each side, because right now it's subtracting. So to get rid of it, we add, and the 28s cancel out on the left side. So we're just left with negative 5k, and then on the right side we have negative 45 plus 28, which gives me negative 17. All right, and then we still want to get rid of that negative 5 so that the k can be by itself. To do that, we're going to divide each side by negative 5. And the negative 5's cancel out on the left side. We're just left with the k, and then we have negative 17 divided by negative 5, which gives me 3.4 if I plug it into a calculator. You can also leave it as just 17 over 5. It totally depends on you. But your answer here is k is equal to 3.4. And there we have it, how to solve proportions.